Hello and welcome to This Explainer. I am absolutely thrilled you're here today. Look, if you're an executive or a business leader who's trying to optimize data operations, drive computational efficiency, and ultimately just get your teams moving faster, well, you are in the exact right place. Today, we're talking about something called Principal Component Analysis, or PCA for short. We're going to distill this concept of dimensionality reduction into clear, actionable insights that you can take straight back to your data science teams.
Let's kick things off with a very real, very pressing question. Is your data actually slowing you down? Honestly, it's a major operational bottleneck right now across almost every industry. We've been told for years, right, that data is the new oil, that we need to collect absolutely everything, but there's a massive pain point a lot of leaders are running into. Bloated data is draining resources. It's eating up compute budgets and, ironically, it's slowing down the exact decision-making it was supposed to accelerate. We're going to fix that today.
So here's our roadmap for the explainer today. First, we'll look at the data bloat problem. Second, enter PCA and streamlining data. Third, we'll look at how PCA actually works. Fourth, driving business efficiency. And fifth, applications and limitations.
Okay, let's dive into part 1, the data bloat problem. Why more data isn't always better.
Modern, massive data sets are creating real operational headaches. Think about a typical real-world data set your company might be using right now. We check age, income spending score, education level, work experience, online activity, location. The list literally just goes on and on. Now, tracking every possible customer variable seems incredibly valuable on the surface. It's kind of like packing absolutely everything you own for a quick weekend trip, just in case you might need it. But when you stack hundreds or even thousands of these variables together, you create immense, bloated data sets. You basically end up lugging around way too many features.
And here is the bottom line impact of having too many features. The costs of this data bloat are severe. First off, your machine learning models become noticeably slower. When your system has to process thousands of variables, compute time completely skyrockets. Second, visualization becomes extremely difficult. Your teams just can't easily map out or understand the data when there are too many dimensions to navigate. And third, unnecessary features just add noise. They confuse the models, which makes your predictive analytics way less accurate. Long story short, this bloat actively hinders your performance.
Moving right along to part 2, enter PCA, streamlining data, the executive's tool for data efficiency.
Think of PCA as the executive's ultimate tool for data efficiency. It's one of the absolute most popular techniques used in machine learning and data science for what we call dimensionality reduction. The entire goal here is to simplify massive datasets without losing the critical information that actually drives your business decisions. Think of it like compressing an image file. If you've ever saved a massive photograph as a smaller JPEG, you already intuitively understand PCA. The uncompressed image is incredibly slow to load, right? But when compressed, the file shrinks dramatically, making it super fast while the important details remain entirely visible. That is exactly what PCA does to your datasets. It compresses the data while preserving the most useful patterns.
So, how does it actually achieve this compression? Well, it does it by creating what we call principal components. Instead of keeping every single original feature, like age, location, and spending score, PCA essentially merges and distills them. It reduces the overall number of variables by creating these brand new ones. These principal components act as streamlined, high-value summaries of the most important information in your data. You drop the bloat, but you keep the signal.
All right, let's peek under the hood for part 3. How PCA actually works.
Now, don't worry, we are not going to get bogged down in heavy math here. PCA works in a clean, straightforward pipeline of 3 main steps. Step 1, the system analyzes the data relationships. It looks at all your variables and checks to see which features contain similar or overlapping information. Step 2, it finds the directions of maximum variation. Basically, it identifies where the data varies the most, meaning the characteristics that actually distinguish your high-value customers from everyone else. These directions are your principal components. Step 3, it reduces dimensions. Instead of using all the original variables, PCA just keeps these new, most important components, leaving you with a much smaller, much simpler dataset.
What's really fascinating about this process is the hierarchy it creates. Because PCA specifically looks for directions of maximum variation, these components are naturally ranked. The very first principal component captures the absolute highest amount of information and variance in your data. The second component captures the next highest amount, and so on. This means your first few components give you the most impactful patterns, which allows you to confidently discard the rest of the noise.
Let's look at part 4, driving business efficiency, the ROI of PCA.
So understanding the mechanism is great, but let's talk about the ROI. Here is exactly how PCA translates directly to your operations and your computing costs. Implementing PCA fundamentally reduces system complexity, and by doing so, it directly improves model performance. Leaner data means your machine learning models process information faster, significantly reducing training time. This directly cuts your computational overhead and your cloud computing bills. Plus, because it removes all that extra noise, the outputs are clearer and it vastly improves visualization, so your human analyst can actually make sense of what the models are telling them.
I really want to anchor this point firmly. PCA is especially important when you're working with high-dimensional data. Look, if your business is handling massive, multivariable data streams, and let's face it, most modern enterprises absolutely are, streamlining it is no longer just a nice-to-have. It is a vital necessity for peak efficiency. You literally cannot run agile, responsive machine learning operations if your data architecture is fundamentally bogged down by too many dimensions.
Which brings us to part 5, applications and limitations, the reality check.
We definitely need a strategic view of where this tool is best deployed. PCA is widely utilized in high-stakes environments like finance and medical data analysis. It's actually the backbone of facial recognition, image compression, and recommendation systems. But we have to be real. There are objective limitations to consider. Because it compresses data, some minor information may be lost. Furthermore, because principal components are mathematical combinations of your original data, they can be kind of hard for a human analyst to intuitively interpret. And finally, PCA really works best only with numerical data. Knowing these limitations allows you to direct your teams to use PCA where it creates the most value without getting blindsided.
To sum this all up in the simplest terms, PCA helps simplify complex datasets by reducing dimensions while keeping the most important patterns. It is one of the single most important dimensionality reduction techniques available in data science today. For a business leader, this is your key to leaner, faster, and much more cost-effective operations. You simply distill the data down to its absolute most crucial elements.
I want to leave you with this final provocative thought. Look at your own operations today and ask yourself, are you maximizing your data or are you just drowning in it? If your models are slow, your cloud bills are high, and your analysts are overwhelmed by variables, it's probably time to have a serious conversation with your data science team about implementing PCA. Thank you so much for joining me for this explainer. Keep optimizing, keep learning, and we'll see you next time.